Hi, good morning. My name is Sunita. Today we are performing the lab of TCP. TCP stands for Transport Control Protocol. In this lab, what is TCP? TCP is a communications standard that enables application programs and computing devices to exchange message over a network. It is designed to send packets across the internet and ensure the successful delivery of data and message over the networks. In this lab, we will investigate the behavior of celebrate TCP protocol in details. Before beginning this lab, we will probably want to review this lab. First one is capturing a bulk TCP transfer from your computer to a remote server. Before beginning our exploitation of TCP, we will need to use Wireshark to obtain a packet trace. Start up your web browser, and click this link. This is the ASCII code. We get this result. Now next go to this link. This is the result we get. Now start up Wireshark and begin packet captures. Opening the Wireshark and click Wi-Fi. These are the packet capturing tools. We insert the upload file. These are the applications that we are also standard responses and queries for the TCP capture tools. Now let's take the 4.2. A first look at the captured trace. I have already done in POC, so I am directly showing these results. This is the results. From the above image, we can understand that we are open the TCP trace file from the traces of Wireshark. Now we are discussing about the questions. What is the first IP address and TCP port number used by the client computer that is transferring the file to link? To answer this question, it's probably easiest to select an HTTP message and explore the details of the TCP packets used to carry this HTTP message. The first question answer is client and IP address is 192.168.1.102 and the port address is 1161, and the second question is what is the IP address of on what port number it is sending and receiving TCP segments for this connection. Destination IP address is 128.119.245.12. The sending and destination ports are 1161 and 80. Now take a look 4.3 TCP basics questions. Fourth question is what is the sequence number of TCP sign segment that is used to initiate the TCP connection between the client computer and device CU Humanius UD. What is it in the segment that identifies the segment of an sign segment? Answer is the sequence number of sign is 0. By flags we identify the sign, that is flag value is 0x002. Fifth question is what is the sequence number of the SYNAC segment sent by link to the client computer in reply to the sign? What is the value of an acknowledgement field in the SYNAC segment? And the answer is the sequence number of sign log is 0, and by flag value of sign log is 0x012. Only sign acknowledgement are set in that. Sixth question, what is the sequence number of the TCP segments containing the HTTP post command? Note that in order to find the post command, we will need to dig into the packet content field at the bottom of the Wireshark window, looking for a segment with the post within its data field. Sequence number of post is 1. Sixth answer. We are done. Now seventh question. Consider the TCP segment containing the HTTP post as the first segment in this TCP connection. What are the sequence number of the first 6 segments of the TCP connection? At what time was each segment sent? So on. The seventh answer is the sequence number of the first 6 segments are packet 4 colon 1, packet 5 colon 566, packet 7 colon 2026, packet 8 colon 3486, packet 10 colon 4986, packet 11 colon 6406. These are the 6 segments. And eighth question is, what is the length of each of the first? Sorry, let us discuss eighth question. What is the length of each of the first 6 TCP segments? Length of the first 6 packets are packet 4, packet 5, packet 7, packet 8, packet 10, packet 11. They are in bytes. And now ninth question. What is the minimum amount of available buffer space advertised at the receipt for the entire trace? Does the lack of receiver buffer space ever the sender? The buffer space, the least window size, that is where it was started in out case in is the case, it is 6780 and the packet is 6. Now 10th question. Are any retransmitter segments in the trace file? What did you check for in order to answer this question? The 10th question answer is no, there are not. We examine the round time graph. Here we seen the round trip time for address space is 192.168.1.102 colon 1161. Here we are showing the round trip graph. In x-axis sequence number, in y-axis round trip time. In x-axis they are taken 0 to 25000 and in y-axis 0 to 50. Question: how much data does the receiver typically acknowledge in an acknowledge? Can you identify cases where the receiver is acknowledged ever other received segments? 11th answer is 1460 bytes. And the 12th question is, what is the throughput for the TCP connection? Explain how to calculate this value. The first TCP segment is 1 byte. The last segment is 164091 bytes. The difference of these bytes are 164090. The transmission time for first is 0.026477 seconds. The transmission time for last is 5.455803 seconds. Difference is 5.494294 seconds. Now throughput is 30222.49235. And now let us discuss 4.4 TCP congestion control in actions. This is the graph. Question number 13. Use the time sequence graph plotting tool to view the sequence number versus time plot of segments being sent from the client of this link. Up to 0.16 seconds, the graph is slowly leaving up, and after reaching 0.25, for every 2.25 seconds, the graph is increasing at the same level. Here the graph is showing. Once check it. Thank you so much.